welcome back. Okay, so we are going to discuss today is parallel and perpendicular lines. Okay, so let's go. So first thing is, as we recap, okay, gradient is being found with y2 minus y1, x2 minus x1, simple as that. Now, to identify a parallel line has a special characteristics. Okay, when a line is parallel, the formula is where the gradient is always the same. Okay, so line 1 and line 2 here has a gradient of m1 and m2, and both of them are the same. So this is a simple testament on how it is being calculated. So you have two different equations. First of all, make them into the y equals mx plus c equation here, and you notice our first gradient here is -2/3, right? Okay, so let's look at the second equation here. So this is in an intercept format. So usually, how do you convert an intercept format to a linear equation or in a gradient form? Very simple. Let's look, x/3 plus y/2 equals to 1, right? So I do what is, I times this whole thing by 6. Okay, so here we'll get 2x plus 3y equals to 6. Rearrange them. So 3y is equals to 6 minus 2x, and divide this whole thing here with 3. So we'll get y equals to 2 minus 2/3x. So you notice here, the gradient here is -2/3. Okay, so it's as simple as that. -2/3. It's easy to observe. So we got this here. Anyway, are they parallel? Yes, of course. You notice here m1 and m2 is the same. So m1 is equals to m2, and same gradient, they are parallel. Okay, now let's look at perpendicular line. In perpendicular line, okay, it's different because perpendicular line meaning they are crossing with a 90 degrees format, where this example is L1 and this is L2, and the gradient here will be carrying is m2 and this is m1. So how are they correlated? As you can see here, m1, m2, m1 times m2 is equals to -1. Okay, so let's look at this equation. Are they perpendicular or not? So they have given you two equations. This all in a more of like in a gradient format. So first equation, easily arranged. You got your m1. Second equation here, okay, as you can see, is just needs some arrangement here and there. And you notice m1 here is 3. m2 here is -1/3. So when you times them together, when you multiply them together, you notice they get -1. So yes, they are perpendicular to each another. It's as simple as that. Okay, so usually this is where perpendicular line properties is being observed. Okay, next week we'll be talking about equation of locus. So this is quite a in-depth topic. So please stay tuned, and till then, have a good day and stay safe.